I'm going to be talking about the Kotlin Serialization library. Has anybody used the Kotlin Serialization library? Played with it at all? Yeah, a few hands. How many people use JSON? How many people use proto-buffers? Yeah, still a few. This is a library that takes into account a lot of different serialization formats, and the real promise of it that I see is in the multi-platform aspect. The ability to share code, not yet with native, but across JVM and in JavaScript. So I got into a little bit of the why, and a lot of, especially Android developers, are saying, Eric, you got up not even a year ago and you said Moshi is the best JSON serialization library. You need to update to Moshi. I heard Jesse talk yesterday about Wire and about updating to OKIO2 in Wire. Wire is going to support generating Kotlin. Why do I need to update here to a new library? And I'm not advocating necessarily to update to this. This is not something that's production ready. It's got a lot of kinks. It's really interesting to see how the API is developed, to contrast that with existing solutions and see the future of serialization in the multi-platform world. So this isn't, take this as like, I'm biased towards certain, I'm biased towards Moshi, I'm biased towards certain serialization formats, and I'm intrigued by the multi-platform aspects of this, and also a lot of the API decisions that were made as this library is developed. Getting started, this is interesting, especially people who haven't played with the library yet. You'll notice here we're adding something to our build script. Right under the class path, we're actually adding this artifact. And then we're applying this plugin into our actual module where we're going to use the serialization library. And Kotlin Serialization, this library doesn't use reflection at all. So you're saying, okay, it doesn't use reflection. Does it generate code? Because I don't see anything here. I don't see any like compile-only artifacts. And then what's this weird build plugin here for Gradle? And similarly, there's a Maven plugin as well. It's actually not generating source code here. And this is where it's very interesting, and it gets very weird too. So it's just going to generate like your bytecode here, and things are going to look weird in your IDE. And one of the ways, as we're going to see in a bit, where we're going to get these oddities in our IDE, a good way to combat that is with the IntelliJ plugin. Something to note here, when you're getting started, you can't just go to the normal preferences, install plugin, install JetBrains plugin. You actually need to download again, because this isn't stable yet, there's no API stability or anything. You actually need to go to the docs here, and on the GitHub page, there's a link to the IntelliJ plugin, and then you'll need to install that from disk on in your IntelliJ preferences. So we're going to see in a bit like where if you don't do that, like I did when I started out, you're going to see weird things. So it's a pretty important step. All right, just the bare bones of getting something running. Here, you'll notice a serializable annotation, and this isn't Java serializable. This is an artifact. This is an annotation in the Kotlin serialization library, and this then lets the compiler plugin know, hey, I need to generate the code here, and then. Again, the bare bones, we can take our JSON singleton here, and then say stringify. We can take proto buffers here, and we can dump And then we notice there's actually this K-serializer API. And at first, it doesn't make any sense. Like, what is the K-serializer? I can just use these methods right above it here. The K-serializer, if you're familiar with Wire, it's like your proto adapter. Familiar with JSON, it's type adapter, or Moshi, the JSON adapter. It's the actual adapter class. And those two methods above it really want to take in the instance of the serializer. If you don't pass in the serializer there, if you just use the two methods above it, like JSON stringify, it'll pull up the serializer from the global map. So it's a good idea to keep the K-serializer around, pass this around where you need to. You actually have an instance of it. And then also that just helps with general code cleanliness and dependency injection. If you have a different implementation of your K-serializer, like we'll see in a minute, then you can pass that around. So in general, pass around the K-serializer. There are a couple of handy factory methods here for lists and sets. These things don't exist in other serialization libraries I've seen, so I just thought they were kind of interesting, so you don't have to go through some of the ceremony to get common implementations. If you already have a K-serializer for your type, you can get a K-serializer for a list of your type or a set of your type, just with the factory method that already exists on K-serializer. And here is something, if you've used JSON before, this will look a little bit familiar. In JSON, there isn't really an idea of a type qualifier. So in JSON, when you have your type and you say, hey, I've got a special way to parse the value of this field, you'll mark @JSON annotation, and then you can pass in, you have to statically pass in a type adapter or a type adapter factory. And this is very similar. You have a serializable annotation, and you say, this number here is special, this long type here is special, use my specified K-serializer. And we'll kind of get into a little bit of how you might implement specialized K-serializers in a couple of slides. So that's very reminiscent of JSON. And fortunately, there's also what I'd say is a little bit more of a flexible API in serial info. This is much more like a type annotation or a type qualifier, like you might find in Moshi, where there's JSON qualifiers. And here we're saying, hey, I have a long, I'm going to need to treat it specially, so I'm going to pass in my annotation, and my annotation's marked with serial info. And then how we actually get this is, again, something we'll see in a few slides, how we're actually going to look at this in our K-serializers, our adapter kind of types. Actually looking up the serial info is a little bit tricky. Similar to serialized name in JSON or JSON names in Moshi, we have a serial name. Again, I wouldn't recommend this. I would recommend just naming your field what it is in JSON. It's much easier to grep that way. But sometimes you can't do that. Maybe there's a space in your actual, if this is JSON, maybe it's your JSON field is named something weird or has a space in it. So use this sparingly, but it exists, serial name. Optional. This is another strange API in that you can write this code. It actually won't compile, which is a good thing, because if it's optional, there's nothing for it. It doesn't have any meaning. It actually needs an optional field. If it's optional and if it's JSON and it doesn't show up, then we actually need a fallback value. So you actually have to both specify optional and the default value. It's kind of a weird API in the sense that for example, in Moshi code generation, if you just specify, or in the reflection artifact, if you just specify a default value, Moshi's already going to realize it's optional. So it's a bit of a redundant API, but it's necessary for the compiler, or for the compiler plugin to notice what's going on here. So you need to mark optional fields specifically with add optional. Nullable values, there's no trick here. They just work. They just work out of the box. Nullability, it's Kotlin. We all know that a Kotlin library is going to respect that. So here's where we get into the custom serialization. This API is much more complex for complex cases than you might find in other current serialization libraries you might have in production. You'll see here we have an object. In this case, I made it a companion object. It can really be an object or a class here. There's nothing special about it being a companion object. It's kind of just convention. But you'll notice I mark it with an @serializer, and then I say what type it's actually going to be the k-serializer for. And again, this is so the global map will know where it's coming from. And this is super interesting because there's no actual factory API. It's all just stored up in the global map in the actual runtime library, and it has to know what type this is going to. So instead of a factory API that says I have a k-serializer for this type, you need to specify it with the annotation, and then it'll get pulled at the right time. There's an oddity here, and this is where I mentioned at the beginning why it's really important to have the IntelliJ plugin, because you'll notice I put these overrides on this object that's not implementing anything. And this is where the magic of the compiler plugin is going to be confusing if you don't have the IntelliJ plugin. The object is actually implementing k-serializer, but not at your source code level. So if you don't add these override annotations, you're going to get a compiler error that says, hey, you're hiding the superclasses, the super type, since this is an interface, the super types save and load methods here if you don't have the override annotation or don't have the override keyword. And if you do have the override keyword, then IntelliJ is going to complain that you're not overriding anything. So install the IntelliJ plugin, because then those errors aren't going to be there in IntelliJ. And so, like I said, this is actually implicitly, or it's actually a compile time implementing k-serializer. And you can do this, you can actually specify this at the source code level, but you don't have to. And if you do, then IntelliJ is going to tell you, hey, you're not implementing the descriptor method, or the descriptor property, rather, that k-serializer specifies. And more on that, again, in a minute. So if you specify that, but you don't plan to implement the descriptor property, then you're going to get warnings in IntelliJ. So I would just leave it off and let it be implicit, or maybe leave a code comment. And platform types. The good thing is here we actually need the serializable annotation on the types that we want to get annotated by default. And otherwise we're going to get a compile time error, which is really nice, because if you use something like Moshi and you're trying to get an adapter for a platform type, you're going to get a runtime error that's like, hey, this is a platform type. Never ever do this with platform types or any types that you don't control. The main reason for those who might not be familiar, don't serialize types that you don't control, because you could be serializing or deserializing implementation details of those types. And then when you update the types that you don't control, those implementation details can change, and then all of a sudden you've got inconvertible formats. So use the public API of types that you don't control to serialize. That's just a side note. The nice thing is here, at compile time, you actually can't do this. You can't get k-serializer types for types that you don't, for platform types at least, and for types that you don't have the serializable method on. And for these types, though, you can specify your own adapters, and this is what you're supposed to do, your own k-serializers. And again, you say the class that it's for, and then you implement these methods. And again, we're going to notice, hey, this is implementing k-serializer, but you didn't implement the descriptor method here. There's a property here that's not implemented. And if you have the IntelliJ plugin, you're not going to get this warning. If you've done this without the IntelliJ plugin, you are going to see this warning, and we're going to see in a minute what the actual property is here that we haven't implemented. So first, the k-serializer is two parts. First, it's a saver. It actually takes the type and then it serializes it. Save is just the word for serialize. And yeah, so pretty familiar API. K-serializer extends the interface k-serial saver, and it also implements k-serial loader. And this is just your deserialize method. It takes in your reader or your k input and then makes your actual type of it. And then finally, that thing that we didn't implement, the descriptor. This, again, the compiler plugin implements this for you. So at the source code level, you don't have to implement this. And you're not going to get warnings about not implementing it as long as you have the IntelliJ plugin. And this has a lot of metadata. And it's also going to be where we see the serial info come into play. So this is like the type annotation for this is a different type. This is a type qualifier. And the way to get this is in our implementation of our k-serializer. We can actually get the descriptor, and then we can get the annotation for the class. So we can say, hey, this is this property has a special annotation on it, and now I need to handle deserializing or serializing in a different way. So now we're going to get into a little bit of the k output and the k input type, the writer and the reader APIs, and also a little bit of generics. So let's say I have this pretty common class. This is my class. I've made a pair class that has two generics, and I want to implement my serializer for it. And this is where it's going to get really difficult not having a factory, because you're going to basically need to implement all of the actual looking up of the serializers yourself. So when you need to implement the serializer for your pair type, and you can't just use like the default @serializable on it, then you're going to need to actually find the serializers for those generic types or for whatever types you need, and then pass them in and actually implement this all yourself. Whereas as like JSON and Moshi, there's these factory APIs where we actually just have the Moshi like client instance, and then we just re-enter the client instance through the factory and look up the adapter types as we need them. With these APIs currently, we need to implement that functionality all ourselves. So we actually need to go look up the serializers ourselves, pass them into serializers that need them. And again, this is because the serialization library needs to handle so many different types. You know, it needs to handle protobuffers and JSON and further serialization formats and user-defined serialization formats. The APIs are really abstract and a little bit hard to reason about, I think, as opposed to proto-readers, proto-writers, JSON readers, JSON writers from like Moshi and Wire. We have these, we have the like K input here, and you actually have to like know where the indices are coming in, and then we can't just exactly delegate to our passed-in serializers. We have to use the special serialize element value to get everything in the right place. And similarly, not as bad, I'd say, with the writer format. But this is really error-prone, and this is why it's really handy in common cases, like when we can just use the serializable annotation. This case is super easy. And it's just all implemented for us. Again, like there's no reflection. All the code from here and here is just implemented by the compiler plugin for us. We don't have to worry about it at all. This stuff just gets really complicated when we start having things like type qualifiers, and then we have to read it off the descriptor, and when we have things just different JSON formats, then actually implementing the serializers ourselves just seems really heavy for folks that are just using JSON or just using proto-buffers, et cetera. Then a lot of this abstraction is just heavier than existing libraries. But in the simple case, like I said, this is super handy. In fact, like, this is all the code you have to write to get this pair to work. If we don't need any custom behavior, then actually this serializer method is generated on our companion object for the paired type. And then this serializer method even recognizes, hey, we've got generic types, and now I'm going to need a K serializer for these two generic types. And if this were, so this will actually give me, the last line there will actually give me a K serializer of a pair with type arguments data and data. And if it were a string, if it were like a string to data, then I would need to pass in a string K serializer and a data serializer. This is actually a pretty nice way of handling generics. And whereas it's a lot different from if you're familiar with like Moshi or JSON. When we have the types, then we pass in a type, and then generic types are resolved from the context of the type that we pass in, and all of this is handled for us. So while this is small code, in a larger picture, this is where a factory would be super handy, because again, we're having to look up the serializer for our data type and then pass it in and kind of implement that factory behavior ourselves. But for really simple cases, this handles everything very generically, and now we have a K serializer that can handle any of the data formats that we throw at it. And we're going to see the data formats in just a minute. And for a lot of us, we don't yet care about multiplatform. And there's this really handy factory method. There's also similar factory methods for class and K-class. But for like Java types where we've got a map of something, or like we're in a library and we just don't know what users might throw at us, we can just look up the K serializer. This, again, doesn't have, there's no factory, so this is just looking it up off of a global map. And if this is if your type here is a Java class, this will pull it off the global map. Currently, if it's anything other than a Java class, it'll actually recreate it'll actually make a new K serializer. So that's why, again, like keeping the instances of your K serializers around is a very good idea, so you don't have to pay the cost of creating a new K serializer. every single time you just need to serialize something. The formats that are currently supported that just come out of the box in the API that are shipped with the runtime library are JSON, protobuf, and KBOR, or CBOR. And the nice part, again, about the Kotlin serialization library is none of the stuff that I've talked about even knows anything about your serialization formats. We can take those same case serializers and then let users use JSON or protobuffers or any of their desired serialization formats, and they're just going to work with our case serializers. So that's the benefit of paying the cost in implementing case serializer with all of that heavy abstraction and all of that error-prone code. Then users can just use this very generically. There's something you might notice here in that our JSON and protobuf implementations don't look the same. They don't implement any common interface. So that's a little bit awkward. They have names that really describe what they do, but like our JSON format, of course, is string-based, is a string format, and protobuffers are byte formats. And the other thing you might notice here is there's no streaming API. So we're going to finish loading up an entire string. We need to pass in a whole byte array. We can't just pass in our buffered source here. So we are going to need to buffer our entire value. This may or may not matter depending on how big your actual payload sizes are. If this this might be a bigger deal if you're on a very slow network, and then you can't just stream in bytes as you start to load. There's also another thing that you might notice that we didn't cover. There's no good way to do what we typically call polymorphic serialization, where we have a dependency kind of on how we're going to serialize. So we typically see this as, hey, my JSON has a field that says this should be serialized as a cat type rather than a dog type. And this isn't supported yet. The best thing we can do is deserialize into a map type, and then we're going to have to re-implement. We're going to have to build up our structure manually. This is kind of a tough problem to solve, especially across data formats. So it is a limitation if again you hit those complex use cases. I think that Kotlin serialization is really good for simple use cases, and especially if you're not using code generation, if you're very heavily relying on reflection, and you have a lot of serialization that you do from disk, it can be a bigger issue. But I think when we get to the actual tough edge cases, that the API just isn't really there yet. So as I mentioned, here we don't have a common interface. These APIs look really, really different. And there's an issue here, issue 66, that you can follow. And Jake raised this in that there's, again, a need for an abstraction for libraries to take in some kind of common saving and loading mechanism, whether users are using string formats or byte formats. And a kind of a workaround for now that doesn't exist in the core library, in the core Kotlin serialization library, but exists in Jake's retrofit 2 converter for serialization, is just a loader and saver function types. So here, here, this is just the abstraction that I mentioned that needs to exist for string types and byte-based types. So if you're using retrofit, this is super easy to use. The library, the only actual APIs of this library are just that you even really need to know are string-based and byte-based, and then the type alias types. And then because it's all abstracted, the core of the converter library, the converter factory library for retrofit doesn't even need to know about your data format because you're just passing in the saver and loader. And hopefully in the future, if these like saver and loader abstractions make it into the core of the Kotlin serialization library, then the API can be shrunk even more. And then actually using this, we can use the JSON or protobufers types that exist already in the out of the box in the Kotlin serialization library, and we can just pass in the method reference to parse and to stringify there, and that implements our loader and saver APIs. And yeah, I want to leave with like the library is really pushing forward towards getting us to think about multi-platform and sharing code. And the nice part about serialization is it's one of those surfaces that really it's a lot of business logic, and we don't. It's very much in the realm of things that we should be able to share with our other platforms. And like I said, native support isn't there yet. JavaScript support is there with a few tricks, but it's coming. And I think that if this isn't the future, I think it's been a big push towards making us think about multi-platform in everything we do. And I think as for the future of like Moshi and other libraries, I think they're going to be pushed that way. I think the other thing is that you'll notice this isn't so dependent on like type APIs, whereas with classic APIs like JSON's type adapter factories and proto adapters, they're based very much around types, and then they're very tied down to like JVM, the JVM type system. And here we just know about K classes, and it's actually just implemented. The actual serialization adapters are implemented by our compiler plugin. And the existing libraries are not going to be able to have the same APIs, as far as I see, to be able to accommodate losing the type system that they very much rely on. And the serialization library, the Kotlin serialization library, has kind of elided a lot of those tricks. And I think the main thing it falls short of is still in those complex use cases where it has a lot of abstraction around the adapters that when you actually need to implement them, as well as when we get into things like polymorphic serialization, and we have to get our maps and build up maps for our types, and then actually build up the types that we need from our maps manually, whereas we already have these things built into libraries that we use every day. So this isn't a call to like go implement this immediately, but I think this is something that we can all play with and we can learn from, and we can push for better APIs. Like, this is still experimental, and there's still a lot of voices to be had. So join the Kotlin Lang Slack. There's a serialization channel in there. File issues when you see them. Also, if you want to see it just like in use, you can check out Jake's SDK search app, and it actually uses his retrofit converter. And checking into the retrofit converter again is a really useful resource. That's where I initially played with Kotlin serialization, and it's where I learned a lot about it and learned a lot about the API choices that had to be made. And if you run into like these complex use cases, like now's the time to bring them up in discussions on the Kotlin Lang Slack and let people know your use cases, especially as we're headed into the multi-platform world, and we're going to be using, if not Kotlin serialization libraries that are going to take a lot of influence from the serialization library from JetBrains here. And that's Kotlin serialization.